and the relevant stuff, what you will be able to see is that the general consumption is basically based on two different things. Okay, so let me see if it is okay. It is visible again. Sorry for the disruption. So typically it has been divided into two things. One is the facility and another one is the equipment, right? Now facility, what does it include? It includes all the infrastructure which is going to support the data center, which includes your cooling capacity, your power conversion based thing. We call them HVACs as well. HVAC kind of in a notation we use for that. We have lighting section, and then we have the actual data center equipments, which are basically the network hardware or the relevant communication channels, and the server and the storage part, right? So if we broadly look at the distribution among these two things, is one equipment is only 36%, whereas facility usage is 64%, and the majority from the facility, it goes for the cooling, right? And why cooling is required, I hope you are aware that whenever a computing happens on a particular machine, even on our desktop, it gets started getting heated up if you do it for the prolonged period of time, right? So think of a data center which are being actually created with an idea that they, for every individual second, they will be processing the user request, right? And that is very, very important. Now every second we are considering, so that means the heat is going to be persistent in that, and if that heat surpasses one typical threshold, there is a chance that your server will get burned, right? It's not only the CPU, it's also the other equipments, semiconductor equipments which are being there. It's network equipments as well, it's UPS equipments as well. So cooling is required for that. So cooling typically takes 50% of the power consumption, right? Now when we are considering a typical power aware scenario, we typically look at that, okay, let's do some kind of conservation on energy so that the cooling process can be made a bit lower. That is what has been required. So generally what happens is, if you typically design a particular special algorithm which allows your servers to do the scheduling intelligently, to do the resource allocation intelligently, then that allows you to reduce the cooling capacity as well. Now how it may happen, it may happen that you have 10 servers on which the load has been distributed, and your intelligent algorithm recognizes that the load can be, the total load of 10 servers can be shifted to only 8 servers, and 2 servers can be put on the sleep state. So in that particular sense, we are trying to conserve 20% of the energy which is being consumed by the servers, right, from that part. And definitely the overall, if you look at the big picture, the 20% of the energy consumption will also happen in terms of your electricity, in terms of your cooling capacity and everything. So that ultimately reduces the emission of the CO2, where that is a greenhouse gas, which is the major contributor towards the climate change that is happening. We have already seen and experienced it in last couple of weeks. But this is one of why this virus has jumped. You know that we, as a human, we are expanding towards the forests, and these zoonotic viruses jump to the humans and so on. There is a lot of theory about it. But anyways, so energy consumption is something which is being required, and that is the primary purpose. And a lot of researchers are working in this particular domain. And for this particular part, they have to look at the consumption that has been happening into the actual system, which is not at all possible, or maybe if possible, it's not viable in terms of economics. So CloudSim allows us to have a lot of classes which can help you to recognize that, okay, if you do certain change corresponding to your algorithm, then what could be the possible energy consumption that is going to happen. So we will broadly look at that particular section of the code. And of course, one thing I forgot to mention, that data centers consume 2% of the electricity production that happens across the globe, right? So this is a huge in terms of the energy consumption itself. right? So let me move towards the project itself. So I'm just going toward the full screen so that you should be able to go through the code. So here we know what is the project structure. If you are not aware, you can go through my previous webinar. You can go through my other videos as well, which are already there on the Superbits Academy, and make sure you subscribe so that you get the notification whenever I am live or whenever a new video is uploaded. So let's quickly come back to the project itself. So this is CloudSim, which has been configured with me. So here there are two specific folders. One is the examples folder, right? Within the examples folder, what you can see is, because today we are talking about the power aware module. So within example, you have org.cloudburst.cloudsim.examples.power package, similarly power.planetlab package and power.random package. So this is what is there in terms of your examples package section. Whereas for the part of the source, if I tell you, so within source, these are some of the packages starting from this org.cloudburst.cloudsim.power. Then we have power.lists. Then we have power.models. Then we have power.provisioners. Provisioners are also being used for this. So power, there are three packages, whereas one is a main and two are the sub packages for that. So we also know this by the name of namespaces as well. Broadly, if we say it's an API, which is going to have certain set of classes among them, right? So before I go and get deep into this particular part, so let me open up any of the examples. So maybe iqrmc.java I'm opening. So if you look at the code, what exactly it is. So I'll be doing it like I start from the example and then I take you towards the classes which are being actually used and where you can change your effective algorithm. Right, that is what is the primary objective, because everyone wants to know where do I go and change the code, right? That is very, very important. So let's first look at what is the structure. So we have a package name defined at the top, then we have certain import section, and then there is a class which gets started. So if you are working on your example, I simply tell you one trick. You make a copy of a class, give it your whatever your example name you wanted to give, and then you can start making the changes to that particular part. So simply, if you are trying to implement any of the power aware scenario, you should make a copy of this particular code, and then you can start making changes. So within this main method, because we know the execution starts from the main method, so here are certain parameters which we have, right? So there are around how many 8 parameters which we have, because this is a PlanetLab based example. So that means this is going to utilize this section as well, which is known as the workload.planetlab, right? This is a section which actually contains the data set from the PlanetLab laboratory. What they have done is they have actually taken care of a particular day, and they noted down the consumption of the virtual machine or utilization of the virtual machine at a particular point of time, right? So every 5 minutes they did a recording of this particular utilization of the virtual machine. So each individual file resembles a virtual machine, and each individual entry is the 5-minute interval of the utilization, right? So let's say right now it's the consumption of or utilization of 24%. After 5 minutes, it's 34%. Then after another 5 minutes, it's like 29%. So if I show you how it could be like, so we have this performance, like the CPU is going to somewhere around 37%, then 36%, 38%. So let's say if I take the reading now, so it's 35%. After 5 minutes, let's say if I'm going to take another reading and it's 38%, so that will be noted. So this is how it has been noted out here. So this is a set of file with 288 entries for the virtual machine utilization. Now, why this is being used? Because this is to be simulated inside the CloudSim, so that because your energy consumption will also fluctuate corresponding to your utilization, right? So if you are aware, you're within this performance, if you go to your CPU, you can actually see that what is the speed which is being utilized here, right? So this is 3.10 right now. It could be less as well, like 3.09. So whatever my speed of CPU is being consumed, that means that that is going to affect my energy consumption as well. And if we are on a power saving mode, you will find in your PCs as well that the speed is going to get reduced to 1 point something in gigahertz, right? So this is one thread which is linked. What is the utilization of your CPU and what is the energy consumption correspondingly? So that's one of the concept which we have now, because we are using this particular data set. So that is why the workload here is mentioned this, right? So this is in quotation marks. So that means if I wanted to utilize the workload of the Planet Lab, maybe this one, this 20110325, then I simply need to do the change here is 25, right? So that's the first step which you should considering. So this is the most important thing, because I need to do a benchmarking kind of thing, and that data set is available. So I need to provide that particular data set notation, right? Or data set name over here. Now, next is if we look at another, now this was the important one. That's why I took it at the first place. Now let's do it in sequence. So enable output is true. That means whenever you run this particular example, it is going to give you the true output, right? That means output will be displayed on the console. Then output file. If it is false, then output will not be sent to file. If it is true, the output will be saved in a file, and you can do your analysis in the later part. Then input folder, that will be corresponding to your class. So if I run this right now, you will be able to see. Let me run this. So because I'm launching it first time after opening the Eclipse, so it will take a bit of lag depending upon how much it will take for the build time. Okay, so it's still at 4%. Oh, so it will take a bit of time. So anyways, in the meantime, it gets started. We can go toward the next one. So output folder. So it says out where the output should be saved if it is going to be in file. So it says output folder. So right now we haven't kept any file for the output. So there is no output folder provided here. But once we do it true, it will be available in that particular case. So here you will find an output folder, right? Then we have already talked about this workload section. Then there are two very important things. One is the VM allocation policy and one is the VM selection policy. Okay, so we have our output available here, right? So it has been running right now. So I'm going to stop it just to show you that how it can be changed. So I'm going to do enable output as false, right? So once I do false, what you can see here is that there is no output, detailed output being displayed, but only the time frame is being displayed. So starting from 300.1 and with the difference of 300, it is going to go for 24 hours, right? So for 24 hours time. So it's in seconds. So whatever it is being displayed here in this particular list is actually the number of seconds, that how much time has been spent into the execution right now. Okay. So generally, when we are not output everything on the console, it generally takes 1 to 2 minutes to finish this particular output section, right? So let's wait a bit. So it's been almost there. All right, so we are stopped here. So the maximum time limit which we have is 86100, right? So now how do I know this number is going to be here? I tell you that as well. But apart from that, the output is also being displayed here. So we will discuss this in just a while. Let's go back to the code again. Now the output was not enabled, so it is false. Now this thing is beneficial when you are doing your testing couple of times, right? Repetitively, you are making some changes into the parameter, and you are not going to waste your time in all that detailed output correspondingly. You just look at that. Okay, what is the final output which I'm getting? Similarly, if you make it true for the output file, you will find that you will be able to have that detailed output in your output folder file, right? So it will again take time. This is again time consuming process. So if you are putting the output in a file, it will take a while to save it. I'm not sure if I stop it in middle, because I never did it before by stopping in between. So I'm just stopping it, and then I'm going to just simply refresh this particular project section. Okay, so resources output, no, without that output is not available, or is there? It's not there. So you have to run this particular complete test for the output file to be displayed into this particular section. So we can do it later on as well. Now, next thing is input folder. This is supposed to be provided corresponding to the path of this particular workload.planetlab. That is what they have done. They have given the class path, direct relative path they wanted to save. Now I'm bringing you back to this particular VM allocation policy and selection policy. Now, VM allocation policy, if you try to look at this particular part, so there are a couple of VM allocation policies which we have, and those VM allocation policies are actually provided under your source folder. And within source folder, you can go to the power section, right? CloudSim.power, if you're doing it side by side. So we have certain allocation policies, that is IQR, the one which we are using right now. Now, how do I know the IQR is there? So if I take you to that particular part, so I'm inside org.cloudbus.cloudsim.power. So here, if you look at these particular set of classes, what we have, so we have the interquartile range, then we have local regression, then we have local regression robust, then we have migration median absolute deviation, then we have migration static threshold. So these are some of the VM allocation policies which are being utilized for allocating your virtual machines, right? So that means when you are writing IQR here, you are actually telling the simulation to use this power VM allocation policy migration interquartile range.java. That class is supposed to be used, right? So this is kind of string marker for this particular class, which should be utilized during the simulation of the CloudSim, and even if it is the first allocation or if it is a allocation after the migration, right? Now that's the allocation part. Okay, now next come is the VM selection policy. Now VM selection policy, here it says MC. So MC stands for the maximum correlation. Apart from that, if you look at the list, again, we have power VM selection policy maximum correlation.java, then minimum migration time, minimum utilization time, random selection policy, right? So this VM selection policy here is actually going to indicating the CloudSim simulator that, okay, MC stands for the maximum correlation. So that means the simulator should refer to the maximum correlation.java class, right? So we power VM selection policy maximum correlation.java. So this is how your simulation get to know that, okay, which VM allocation policy and which selection policy. And even the PlanetLab example and random examples are given the names corresponding to that. So we have actually opened IQR MC.java. So that means IQR interquartile range for VM allocation, and MC stands for the maximum correlation for the VM selection. So this is some notation which has been used by the developers of the CloudSim. So you can also consider the similar kind of nomenclature for your example. Then there is a safety parameter which has been used. This is corresponding to certain algorithms only. So IQR utilizes that safety parameters, so that if I wanted to do the migration, I need to check that, okay, I hope whenever I'm doing the migration to a particular host, it is not going to overload that particular host in the certain sense, right? So these are certain pre-parameters or attributes that you are supposed to provide for running this particular power aware simulation in the CloudSim. Okay, Now, all these things are supposed to be passed on to the Planet Lab runner. Now, this runner class is the main class, which is going to actually initiate your power aware things. So where this runner class available? So Planet Lab runner, either you can right click and go to the open declaration, or you can go to this particular uh, uh, this org.cloudburst.cloudsim.examples.power.planetlab section, and there you can actually see this Planet Lab runner. So Planet Lab runner will be here. The random runner will be in the another namespace. So once you go inside this Planet Lab runner, you are actually able to see that what exactly happens in its particular constructor. So it is going to call it super class, right? So where it is the super class, it's a runner abstract class. So this runner abstract class actually exists inside this org.cloudburst.cloudsim.examples.power. So finally, this is the class which is going to be called for the real action. So we are going to that particular class, this runner abstract here, and this runner abstract actually do certain initialization for you. Now, initialization in terms of the input folders for the workload and the start method, right? This is the start method from where your execution actually gets into the picture. Okay, and this execution is going to have your VM allocation and selection policy instantiated from this step itself, right? So in case if you are considering your policy, you have to consider working around this particular method. Okay, so this is where your example goes and initializes the complete steps, and after that it goes to the console and displays you every individual thing, right? Now how these all stuffs are being working out. So let me take you to this particular start method again. So please pay attention if you are considering your implementation corresponding to changing the algorithm, right? Corresponding to migration part and allocation part, right? So this is where you actually come in place. You actually provide the allocation policies. Okay, so let me take you back at the above again. So start method, within start method, what you are trying to do is to get the experiment name and get the allocation policy, right? So before this start method is going to be called, this get VM allocation policy is going to get initiated, right? So once we go inside this particular part, you can go through this code above on your own. What exactly it does is it initializes certain objects for you for the allocation and selection part, and then actually it starts doing an if else loop. Now we know that we have a IQR based allocation policy. So allocation policy will be initiated corresponding to it. So this is where corresponding to your IQR, the selection of the VM allocation instance is being provided. So VM allocation policy instance will be initialized from here. Why? Because IQR MC was being provided in these two particular parameters, and this parameter was actually used in runner abstract class inside the get VM allocation policy method, and from there it is going to match it. Okay, which particular VM allocation policy was being asked for, please start the instantiation from there. So this is the key, the very first key while you are considering to implement your work, right? So let's say you have created your own policy or algorithm, and now you wanted to call them through the example. So you should be working around this particular part. You should add this one more section of if else thing, and then you can actually go and work around your algorithm call. Okay, so that's the very first step corresponding to calling your own algorithm. I am just coming towards that where you can implement your algorithm. That will take another 10 minutes, right? So this is first thing which you should keep in mind inside the runner abstract class. Okay. And the selection policy which has been provided, that has been passed from here itself, so it will automatically call it from the inside. So this is one section that we have. Now let me pause this example part here and let me take you towards the different set of allocation policies and other things. So we have basically these three different packages for the power. So this one is the main, that is the org.cloudburst.cloudsim.power. The next one is the org.cloudburst.power.list. It contains only power VM list. So that's just only a supplementary class it has. And then we have the org.cloudbus.cloudsim.power.models. Now this model is actually corresponding to your machines, right? So you have servers. Take any data center. If you look at a data center, your data center will consist of real data center will consist of variety of different servers. Every year data center providers add on the capacity uh, to your infrastructure. So what they do is, let's say today a data center is going to take or buy 100 servers and add on to their infrastructure. So today's technology is different. After 1 year they are again going to do some upgradation in their hardware. That technology will be different, and so on. So year wise they do the upgradation, maybe month wise they do the upgradation. So what exactly happens is, they may have a couple of different kind of server configurations. Each server configuration may have a different kind of power consumption model. Right now, for that you have to define certain thing inside the cloud sim, right? So it's very, very important to understand that particular concept as well. I shown you this particular part, that we have a power consumption on our local machines as well, and this particular speed actually corresponds to that, and this speed actually generates that, okay, what power consumption will be done. The same happens with these things as well. So for CloudSim, if you want to simulate your type of server, then we have to look around this particular section where you are going to define the models corresponding to your particular system. So here, if I show you, now this is what we have corresponding to a HP Pro Lend MI machine, right? So this is a series of, I think, 110 G3 Pentium D3 3900 and 30, right? So 300 megahertz is the speed. So that means 3 gigahertz is what they have. 2 cores they have, and 4 GB RAM is being provided. Now this benchmarking information has been taken from this particular source. So you can, for detail, you can go to that particular part. Now next part is that how much in watts, right? At how, if you count this number, 1 2 3 4 5 6 7 8 9 10 and 11. So if I'm not at all consuming the system or this particular server, 105 watts is what it is going to utilize. And if I'm using it to the full throttle, then 169 watts this particular one single system is going to consume, right? So this is the power model corresponding to that particular server. So if you are considering your own server to be integrated inside this particular system, then you should be looking into creating this particular type of class for your model as well, right? So similar thing you will find in another HP model. This is another 3075 model. This is another IBM model, right? So they have their power consumptions, right? And so on. So there are a lot of models which are being provided correspondingly, and you can consider or take this as an example, and you can generate your own model as well, right? So that's for the system hardware system representations, right? What the power consumption they might have. And next part is, if you look at this particular section, that is your org.cloudbus.cloudsim.power. So here you can actually see that there is a power data center. So if I open it, you can see it has been extended from the data center class itself. So a lot of functionality comes from this class only. There's hardly one small change which is being done corresponding to the update cloudlet processing method, because we need to call the method that is optimize the location corresponding to your workaround thing, right? So similarly, we have power where data center broker. Now this is again extending the data center broker class, right? And you have a process VM create method overrided here. There is only one method. Then we have power data center non-power aware. Now the difference here is that this particular class is not going to take care of the power consumption correspondingly, right? Then we have power host. Then power host is something which has been utilized or which has been again extended from the another class, that is host dynamic workload. And if I go inside this host dynamic workload, you can see ultimately it has been extended from the host class. So they all are interlinked. What we have already seen in our this basic CloudSim package, right? So the functionality has been only extended corresponding to power aware thing, right? So wherever the power consumption is required to be logged, that has been extended and worked out. Similarly, you have Power VM. Now within Power VM, you have to provide the utilization history, right? So why host has been extended and VM has been extended? Because we need to have a utilization history. And why that history has been required? Because we need to actually track that what is the energy consumption during that particular utilization history. Now this utilization history is always corresponding to what you have in your Planet Lab data set. So whatever the number of entries you have, the utilization history will also corresponding to the same number, right? So we have 288 entries here. That means my Power VM utilization history will also have the similar number, right? Now let's come to the actual point, right? So because we are looking at the power aware thing, and that power aware thing is supposed to be practiced when the data center hardware is running. Now for doing all that stuff, there are two things we consider, right? So the very first thing that we consider is corresponding to that, okay, whenever a particular virtual machine is created, it should be allocated to a particular suitable host so that the energy consumption can be limited, right? So that's the one first step that you can consider, right? So a lot of people work on this kind of algorithm, right? So they consider it that instead of doing migration at the later point of time, let's do it right away at the first step and keep the things tracked. But now there is a point to consider, because we are saying that Planet Lab benchmark data will be used. So in that particular sense, the utilization will be again fluctuating. So if it is fluctuating, do we need to do the migration at the later stuff? Yes, definitely we can consider that, or we may neglect that as well, depending on what research work you are working on. Now, coming on to the second type of use case, where we say that, okay, let's do the allocation in the first step, and let's do it with the suitability factor that, okay, first come first serve, or whatever that part. Or maybe we consider the other use case as well, that let's do it for the best case. Okay, but still we are going to track the system, and we can see that, okay, if my utilization is reduced, can we shift the virtual machines to the another host so that we can remove or put those hosts into the sleep state, so that the energy consumption can be reduced. So in that particular sense, we can consider the allocation policy as well as the VM selection policy, because for that what you need to consider is that, okay, which host to take care of. I have 10 different hosts. So I took an example that, okay, 10 hosts and 10 virtual machines are being allocated, one virtual machine on each host, right? Now we can consider that, okay, let's look at the possibility that we can move two virtual machine to the another host. Okay, and once we have that, so we have 8 hosts running and 2 hosts which are in sleep state. Now let's another cycle in another cycle we consider that, okay, on those 8 hosts which are operational, other than the 2 hosts which are already being put into the sleep state, what is the possibility? Can we again do certain kind of clubbing of the virtual machine? So in that particular sense, we need to consider, okay, which host to select, and then which virtual machine to select from that particular host, with how we can move it. So if I'm considering that which particular host to be selected, then my host utilization should be considered correspondingly. Now there is a benchmark. If my host is consumed, the host computation utilization is consumed over 80%, it is considered as a overutilized method, right? If it is below 20%, it is underutilized method. So there are two different sections we have. One is overutilized host, one is underutilized host, right? So both the cases are to be considered, right? So all the allocation policies actually depends upon this particular class, that is Power VM Allocation Policy Migration Abstract, which is in fact again extended from the Power VM Allocation Policy Abstract. That is the first class, right? So let me make it full screen. So this class has been extended. So there are these two classes, these abstract classes. The base class is Power VM Allocation Policy Abstract, and then we have Power VM Allocation Policy Migration Abstract.java, right? So this particular class is actually going to have the actual implementation. So let's go inside this particular abstract class and then look at that. Okay, get overutilized methods, right? So that is one of the method which we have, and then we have get underutilized method. So both these cases are being included over here. Apart from this, because this get overutilized method and get underutilized method both are calling is overutilized and underutilized methods, in that particular case, now we actually go to the allocation part. So we go into this power VM allocation migration interquartile range class. So here what we have is we have the implementation of is host overutilized method. So this is the actual method where you consider that, okay, what is the possible threshold that I need to look at? How do I choose this particular host as a overutilized host, or is working fine, is not overutilized, and no VM migration is supposed to be uh, considered from this. Okay, so this particular method is considered by those researchers who are actually working on the threshold part, right? So if I'm working on a migration policy which is corresponding to VM allocation, this is one of the most important method which you should be considering. Most important method, right? So every individual, because your migration VM allocation migration is actually depending upon the logic that how you choose your host to be overutilized. Okay, so that's very important. So you should be considering this particular migration policy, because the migration is just only first step. You consider that which particular host to be selected for the next cycle of migration of the VMs, right? And that has been decided by this particular is host utilized method. Okay, now next part is, now I know the host has been overutilized, that has been recognized. What's next? What's next? Next is I need to find out, let's say that host is having 3 or 4 virtual machines running on it, and we need to see which virtual machine is to be moved out from that particular host and to which particular host, right? So for that particular part, your VM selection comes in the picture. And this VM selection, let's say we are again talking about IQ or MC example. So this VM selection is actually going to have a get VM to migrate method. Now this is the second method which you should be considering, right? So let me show you by maximizing it. So I have actually opened this particular class, Power VM Selection Policy Maximum Correlation, and that has been opened. And within this particular, because this selection policy class is being extended from the Power VM Selection Policy class, which is an abstract class for these set of classes. So here, get VM to migrate method will be utilized for defining the algorithm that how your virtual machine is going to be correspondingly selected for the migration part, right? So this will run on the host for selecting which VM. So 4 VMs, let's consider on the basis of this particular algorithm, we were able to track out 2 virtual machines which are actually doing the maximum correlation with the particular host, and then we can actually go for the migration part. This is the half step. First step is host utilization, is host overutilized. Once the host is selected, then you have actually go towards the selection part, and then selection can be considered from the on the basis of the correlation. Now correlation here is done on the basis of get utilization metrics that has been generated correspondingly. So it's again purely depending upon your algorithm. The developers of the CloudSim, they have considered this algorithm for the maximum correlation. You may consider your own algorithm. So if you are considering to create your own algorithm for VM migration and selection, then you should be making a copy of both. So let's say I make a copy of this Power VM allocation policy migration interquartile range.java, and then I implement my own is host overutilized method in that, and all the supportive methods. And similarly, if I also make a copy of another power VM selection policy maximum correlation class, and then I go and work around the get VM to migrate method and all the supportive methods which are required for the calculation of whatever the algorithm I have. So it's more or less a software engineering basically. The only point is host overutilized and get VM to migrate correspondingly. Now, how do I make a copy? So if you have given some attention to this particular part, the class has been extended. This selection VM selection class has been extended by power VM selection policy. So that means you can also do the new class. So let's say I'm creating a new class by going to file and new section. Let me maximize it for you. So file and new, and within new I'm going to do a maybe from instead of here, because I'm going to work around in this particular section. So I'm going to create a class over here. Let's say I give it a name pvm select for super widths, right? Which class to be extended? That super class I need to define. So I can define it as power, or maybe I can browse for quick access to all the set of classes. Power VM selection policy. So this is the class which I'm looking at. This is from the power section. Okay, great. So once I'm having that particular part, inherit the abstract methods constructor from the super class, and I doesn't require any main method, so that's done. So if we look at this particular section, we have a class ready, and we can simply write our algorithm over here. Okay. Now there is a question from Shanmugam, if I'm pronouncing it right, and pardon me if it is wrong. So question is that how to implement ant colony optimization. So implementing the ant colony optimization is like basic algorithm of ant colony optimization is already there. You have to consider it. I'm not sure for what purpose you are looking at, but what you can do is, let's say you are trying to do it for the VM selection, then you should be considering to implement it over here. Okay. If you are considering PSO, then you should be implementing here for the corresponding VM selection part. If you are considering for let's say doing the allocation by using the genetic algorithm, that's again this place, right? So this is the pinpointed area for you if you are doing it for the VM selection, right? So if you are doing it for the allocation part and for finding out the host mapping, then you have to consider the different place as well. Okay, so I hope I have answered your query here itself. So let me take you to the another part. So we know how we can create our classes, right? So we can extend our classes. Similarly, you can extend your power VM allocation policy class by extending this power VM allocation policy in migration abstract. So this is how you consider corresponding to your work itself. So okay, so for VM selection, I've told it Shanmugam. So this is for the VM selection only what I answered for you. So for migration, you should be considering this power VM allocation policy migration abstract class to be extended, right? So this is where you consider your implementation of migration and the VM selection classes. So that's pure implementation part. So you can consider writing your code in these set of classes, because they will be automatically called through that runner abstract class by instantiating the classes. Now the change which we need to make corresponding to that particular section is, so let's say I'm considering this PVM select for super widths to be considered for this particular example. So let me open that example IQ or MC, right? Okay, so here if I take MC1 is the indication for that particular selection part. So this is supposed to be done corresponding to your. Let me take you to the example again. Let me open it. runner abstract. So I need to open runner abstract. Okay, it is here. So within runner abstract, if you see, what we are considering is, for VM selection, we are actually calling this get VM selection policy method. Okay, so I'm going to go inside this particular VM selection. So we have this MC already here, right? So because I have implemented my new class, I'm considering it because I have not written the code, but yes, I will be able to instantiate it. So I made a copy of this particular if else part. Instead of MMT, I'm going to write MC1, and here power VM selection policy, instead of this particular part, I'm going to write power VM PWVM. Now if you see, it has actually been displayed here, PVM select for super widths, right? So this is what change I need to make for the making change of the selection policy. So let's say I implemented my own algorithm. Okay, even though right now it is going to give me an error, but still I can show you by running it. Or maybe the selection is not being provided in a way it should be, right? Because I've not written any code. I've just created the class. I've not written any code over here, so there is nothing which is going to be worked out. But still, you can simply consider. The only thing what I can do is, let's say this is print, print. Okay, that is supposed to be got from the log dot print. Let's say I'm considering print line. So let me see if it can print for me, so that we can show you that actually this has been called. This is the new class that is being called for the VM selection. Okay, so we are doing it with the stars. So let me run it and see what actually it is going to show me. So right now the first allocation has been happening. Okay, so great. So I'm going to stop it for a while, so maybe we can see some output. Let me run it again. Okay, so I might have missed it again, but oh, great. Again. Okay, so you can see here again, this is the new class that is being called for the VM selection, right? Okay, good afternoon, sir. Great. So Deepika is saying the voice is not clear now. Is it clear now? I hope it is clear. Can somebody confirm? If you're trying to implement any of the power. Okay, in the meantime, somebody confirms me is the audio is okay or not. I'm taking the question of Muhammad Alzi. He is asking, could you implement a sample migration of VM here? Mohammed, right now it's out of the scope because we have considered only the webinar for 1 hour. I can definitely do that for the next one. But I've actually shown you that how you can actually implement your work, right? So you just need to consider the extending of two files. One is the migration and one is the selection. You write the code over there. Rest all is done by the system itself, right? So you need not to make any changes. The only point is your particular algorithm should be working fine. So even if you look at the part, it says that this is the class, right? So if I show you, it says this is the new class that is being called for the VM selection. So even though I have not written a single piece of code over here in the custom VM selection class, the same can be done for the VM migration as well. But some logic is to be put, otherwise there will be an error, right? So you can do the similar stuff over there. So considering that particular thing, you can do the extensions, and rest of all will be taken care of by the cloud simulation. Now next, Deepika is asking, how can we implement security on information and location in CloudSim? So, Deepika, if I tell you frankly, there is not much support which has been provided for the implementation of the scenarios where you can consider the security part, right? There might be certain extension which has been available, individual extension which is available on the GitHub. You can check that, but I'm not sure it has been possible. You may consider iFog Sim for this. There might be a class implementation over there, but I need to check before I confirm you. Okay, so for security implementation, it's a challenge. But for the location, now for location, what you can consider is, let me show you one example. If you go and look at the example one, and if I take you inside the data center, create data center method, what you can see is within the parameters of your data center characteristics, there is a time zone section, right? Now, if you can do some logic, like, if I don't know what exactly you wanted to implement, but if you wanted to do some implementation corresponding to the location, you can use this parameter and do your logic around this particular parameter to check that, okay, what is the location of this particular data center and how it can be considered for your work, right? So that can be taken care of correspondingly. Another question that is again from Muhammad Alanzi. Sorry, I'm not able to. Okay, Alanzi, right? Sorry, pardon me for pronouncing it wrong. So here, how we can select the underutilized and overutilized host. So I've already discussed about this just a couple of minutes ago. You can rewatch this webinar. It will be available correspond after this particular broadcast is over. The recording will be available on the channel, and you can go through that particular section in detail, right? So just to give you a quick pointer, in any migration policy, right, because it is extending the Power VM allocation policy abstract method, what you need to consider is you have to actually look at this overutilized method, right? Is overutilized. So if you are considering your example, you can put your algorithm to put